Welcome to Techie Wise. So in today's session, we will be dealing with the classical encryption techniques. So before moving on to the classical encryption techniques, we can have a brief look into what is encryption. Okay. So if I am sending a plain text, any intermediate entities will be able to read this content. So what should I do? I should convert this plain text into a scrambled form, which is called as the ciphertext. So this scrambling is going to be the encryption technique. So how I am going to convert my plain text to its equivalent ciphertext is going to be the encryption process. How this conversion should be? It should be reversible. So if I am converting a 2-bit plain text, then it should be converted to a 2-bit ciphertext. Only then it can be reversed. So this encryption technique can be broadly categorized as substitution technique and transposition technique. As the term suggests, substitution. So there is one character of the plain text is substituted with some other character. It can be a number, a symbol, or any other thing. So substitution. So one character is substituted with another character. That is substitution. Next comes the transposition. That is changing the position of the plain text characters to convert into a ciphertext. That is, first character of the plain text will be changed as 5th character in the ciphertext. Second character will be changed as 9th character in the ciphertext. Like that, they're changing the positions. So this is the broad category. Now we can, before moving on to the modern cryptographic techniques, we can have a look into the classical encryption mechanism that is used in the traditional earlier days. So first, to start in the classical encryption, we can see the techniques which comes under the category of substitution mechanisms. Here, the first example, what we are going to see is the basic one, which is the Caesar cipher. As the name suggests, it was used by Julius Caesar, proposed by Julius Caesar. Here, the techniques, what we are going to use is we are going for a symmetric key mechanism. Symmetric means same. The receiver and the sender as well as the receiver will be using the same key for performing the encryption and the decryption. So here in this case, in the case of Caesar cipher, key is a numeric value. Key is a numeric value. Okay, so here in all the classical cryptographic technique, the traditional methodology is we will be representing the alphabets with a numeric value, that is the positional value of the alphabet. Positional value in the sense A will have the numerical value of 0, B will have the numeric value of 1, like that it goes on to Z will have the numeric value of 25. So here in this example, we can take key as 5. Key as 5. And our plain text message to be encrypted is technique. So this is the plain text message. So this is what we are going to proceed with the encryption process. So each character is going to be substituted with a character which is 5 characters ahead, right? So here T. U, V, W, X, Y. So T will be substituted as Y, and E, F, G, H, I, J. So E will be substituted as J. C, D, E, F, G, H. Like that it goes on. So this technique will be substituted as J, Y, H, M, S, N, V, Z, J. So this is the corresponding ciphertext. So if I want to proceed with the decryption process, the receiver, so here the sender is going to use the key and then he is going to convert it as a ciphertext and then it is transmitted. Now, the intermediate person don't know the key, so he can't read the message. But what about the receiver? The receiver knows the key. So here the thing is, there is a agreement between, the consideration is there will be an agreement between the sender and the receiver with respect to the key. That is, they know the key in a confidential way. What the receiver can do? The receiver can reverse back. So here from Y, 5 characters below. So it is going to be T. Like that it goes on. So the ciphertext. So what is going to be the generic formula for ciphertext? So ciphertext C is equal to plain text character P plus key a numeric value mod how many characters in the alphabet? 26. And how about the decryption part? P is equal to ciphertext minus character of the ciphertext minus numeric value key mod 26. So encryption is nothing but converting the plain text to its equivalent ciphertext, and decryption is converting the ciphertext to its equivalent plain text. Alright, so that's it with the Caesar cipher. So now we can have a look into the, we are going to discuss is the Playfair cipher. Here the drawback of the previous mechanism, that is Caesar cipher, is the intruder can easily identify the key. How he can identify the key? Here in this example you can see both the characters E are replaced with the same character J. So by means of analyzing the frequency of characters, he can easily match the plain text character. By that way he can get the key. So if we get a key, then he can easily retrieve the plain text. So in order to enhance the complexity, we will be discussing the further encryption methodologies. So one such is the Playfair cipher. So here keyword is used. In the previous scenario, key is used. So here in this case, keyword is used. Let us start with an example. Consider a keyword of monarchy. Keyword is monarchy. Here it is not a single step process. Instead, it is going to involve a sequence of processes. Here, the keyword is used to construct a 5 cross 5 matrix. So, in a 5 cross 5 matrix, how many values can be placed? 25 values can be placed. So in this 5 cross 5 matrix, we are going to try to accommodate all the English alphabets. So how many alphabets are there? 26 alphabets. So this 26 alphabets, we are going to try to accommodate in the 25 slots. How we are going to deal with? So in order to construct the 5 by 5 matrix, we are going to start with this keyword. So here, before proceeding with that construction, we will be removing all the repeated characters from the keyword. So here in this case, all the characters are unique. So we are going to use the keyword as such. If suppose, let us consider my keyword is banana. So here in this case, I have so many repeated characters. So what I will do, I will remove all the repeated characters. Only BAN will be used to fill up the 5 by 5 matrix. So here, let us start with this keyword monarchy to construct the 5 by 5 matrix. So, I'm going to use these characters to construct it. 5 characters in a row. So, MONARCHY. The remaining spaces are filled with the remaining sets of alphabet. So, the next is already A is there. So, the next is B. C is already there. So, next is D, E, F, G, H is already there. So the next comes I. So here, as already discussed, we are going to accommodate 26 characters in this 5 by 5 matrix. So how we can accommodate? At least 2 characters should be placed in the same slot. By analyzing the frequency of characters, they have proposed the algorithm in such a way that I and J will take the same slot. Okay, then I and J is going to place in the same slot, and next comes K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So this is how the 5 by 5 matrix is going to be constructed. Right. Now the next step is going to proceed with encrypting the plain text. So using this matrix only, we are going to encrypt the plain text. So here this plain text is going to be encrypted as 2 letters at a particular point of time. So 2 letters. So here plain text is going to be encrypted as 2 characters at a particular point of time. I am going to 2 characters from the plain text and convert it into a 2-character cipher text. So here the example is the plain text. What we are going to use is substitution technique. Substitution technique. So this is my plain text. So here I am going to convert this plain text to an equivalent cipher text. So how I am going to convert? 2 characters at a particular point of time. So here again some pre-processing is required. I am going to group it as 2 characters, right? Block of 2 characters. So S, U, 1 block. B, S, T, I, T, U, T, I, O, N, T, E, C, H, N, I, Q, E, and the last character is empty. Sorry, it is not full, right? The last character is not full. So I am going to use filler. So I can use any filler, but it should be it should be known to the receiver as well. So less frequently used character can be used as filler. Here I am going to use X as the filler. So this is how the pre-processing is done. So here the constraint is, if a block has same characters, 2 characters are same, then I will be going for I have to reshuffle it. So for example, let us take balloon. Let us take balloon. So consider this is my plain text. So here first pair is BA. Next pair is LL. So we can't go like that. So instead we will be inserting a filler between these 2 characters and then we will regroup it. LX, LOON. So this is how we will be proceeding with. If 2 characters remains the same in a block, then we will be inserting a filler and then we will be proceeding with regrouping. Right? So this is how the pre-processing is done. So the next comes the cipher text. So plain. So the next we can move on to the ciphertext part. So here it involves 3 different strategies. If the plaintext unit falls in the same row of the matrix. So for example, same row of the matrix. So here consider this pair B, O, N. Consider this pair O, N. Same row of the matrix. So how it is going to be encrypted? Replace the letter by the letter to its right. So ON is going to be replaced with a letter by the letter to its right. So O is replaced by the letter to its right. That is N. And N is going to be replaced with the letter A. Let us consider one more pair like this. CH. So CH falls in the same row of the matrix. So replace each letter with the letter to its right. So C is replaced by H. And H is replaced by Y. So this is how the encryption takes place under this category. If the plaintext pair falls in same column of the matrix, so consider this pair BS. So BS falls in the same column of the matrix. So replace the letter by the letter beneath it. So here B can be replaced by either I or J. Right? So here in this case, let us take I and S is replaced by the letter beneath it. That is X. Right? Let us just, in order to get more examples, let us take the plain text as banana. B-A-N-A-N-A. So banana, B-A. So here BA, replace each letter with the letter. Here BA falls in the same column of the matrix, right? So B is replaced with the letter beneath it. So I can either go for J or I. So let me go as I. And A is replaced by the letter beneath it, which is B. And next comes NA. NA falls in the same row of the matrix. So N is replaced by the letter to its right. A, and A is replaced by the letter to its right, that is R. Let us consider there is a pair AR in the plain text. How it is going to be converted? Or let me take it as NR. Okay, consider the plain text pair is NR. So N is replaced with the letter to its right, that is A, and R is replaced with the letter to its right. So here it is going to be considered as a circular matrix. To its right in the sense, this is M, right? Similarly, let us consider a pair KZ. KZ. So K is replaced by the letters. This pair falls in the same column of the matrix. So K is replaced by the letter beneath it, which is T, and Z is replaced with the letter beneath it. So again consider it as a circular matrix. So it is R. So this is how the encryption takes place. And one more combination is, so here till this point we have discussed if a pair falls in the same row or falls in the same column. If the plain text unit falls in different row and column, how it is going to be replaced as? Consider SU. So S is in this row and U is in this row, right? So same row and, different row and column. So then in that case, replace the letter with the letter in its row and in the column of the other. So S is going to be replaced by the letter in its row and in the column of the other. So it should be replaced by N. Similarly, U should be replaced by the letter in its row and in the column of the other. So it is X. So just let us consider TI. TI, different row and column. So T is going to be replaced by the letter in its row and in the column of the other. So it is yes. IT. So it is going to be replaced with the I is going to be replaced with the letter in its row and in the column of the other, which is K. So this is how the Playfair mechanism holds good. So again, the decryption is going to be the reverse way. So if I'm going for same column, same row, beneath it in the same. So here in this case, same, if the plain text pair falls in the same row, then we will be going for replacing each letter with its letter to its right. Whereas in the case of decryption, it is going to be to its left. That's it. Similarly, beneath it, if it is going to be this column, whereas in the decryption part, it is going to be above it. That's it with the Playfair cipher. Thank you.